I guess we can go ahead and get started. Sarah, is that all right? Okay, so let me go ahead and introduce myself. First, let me say that I suffer from massive amounts of ADD and I easily get sidetracked and I will go on a tangent. So if I start down that route and I start going too far, just say something and I'll bring it back to center as best I can. But what I want to start with is let me just introduce myself. My name is Jason Anderson. I guess my official title is lead operator, operations lead for zData. Essentially what does that mean is I manage a team of DevOps engineers and then a few interns too. So, Sarah asked me to speak today in front of you all about TensorFlow. Do you guys know what TensorFlow is by a show of hands? And gals, the way I'm, being PC there. Good. Okay, so you probably honestly know a little bit more about it than I do, and here's the reason why. I'm not a data scientist, I'm not a mathematician, and I'm not a statistician. To be honest, I had stats like in college 20 years ago. Somebody talked about like housing data. Funny enough, our senior project was predicting housing prices with a bunch of data using stats though. And that's about where it stops for me. For the last 20 years, I've actually been a software engineer, basically as a lead developer, senior developer, team lead, and manager. So the question is like, why am I here today to talk to you guys about TensorFlow? Well, the short answer is because Sarah asked me to. Outside of that, I do know what it is. According to Google, I guess you could say I'm qualified to talk about it. Here's
You're
my flag.
GCP certified.
Data engineer. So really what that means is like I was challenged to go ahead and get my certification as a data engineer. And I have to say this, for anyone who ever looks into it, it's probably one of the hardest certificates I've ever gotten. I actually failed the first time I took it, which if you know me, was unbelievable. But I did not fail the second time. So, but honestly, I have very limited use or interaction with TensorFlow. But TensorFlow is still important to me, but for probably different reasons than what is important for you guys. TensorFlow for me is important because when I have a potential client come to me and they talk about wanting to do like machine learning and they start throwing out keywords like TensorFlow, PySpark, there's a whole bunch of other ones. I'm more interested in how am I going to support and what type of system am I going to stand up for them. Okay? So what I thought I'd do today is I've put together a list of notes. I'll just kind of go down through my presentation, ask questions, but if they get too in-depth, I'll be like, I don't know, ask a data scientist. But I'll do my best to answer it. So, and basically what I'm going to do next is just, kind of a quick overview. TensorFlow was developed by Google. If you guys don't know that, gals don't know that. It was basically brought forth and presented as being open source by them. If you read all the hoopla about it, it's been heavily adopted and there is a lot of applications where it's actually getting used right now. We'll kind of talk a little bit more about that a bit. But interesting enough, if you do a Google search, or in my case, DuckDuckGo, on TensorFlow and actual usage at Google, you get kind of mixed results. And I think that's interesting to point out because Google has a history of building really cool technologies. Hadoop is another one, the Hadoop file system. Turning it over to open source and then moving beyond it internally, meaning typically that if they've released it for public use, they probably have already another version that they're using internally for themselves. Okay, and there's reasons for that. I mean, honestly, they have some proprietary stuff that they just don't share with everyone else, which makes me want to know, well, what are they using internally? And I'm not going to cover that today because I really have no idea. I'm just curious to see what they're actually using. So I'm just going to kind of jump down through it. It was basically developed and written in C and C++, which is one of the reasons why it's actually quite fast. But if you guys want to use it and interact with it, and we'll look at some sample codes here in a second too, Python. Python is basically the main language that you use to interact with. Now I mentioned that I'm a software engineer. My background has primarily been in .NET, so like C# for like the last 10, 12 years. So curious enough, there's been some projects around what I would call a wrapper, so that we can expose the functionality through .NET. So if there's some interest in that, let me know. We'll take a look at that as well too. Okay, so other just fascinating information about it. Are you all familiar with Jupyter Note? I see a lot of head shaking yesterday. So you guys already know quite a bit about it. All right, so I won't talk too much about that. Okay, so obviously
we
yes.
do have all levels of people that usually attend, from like some people don't know what machine learning is to they've implemented neural nets and everything.
Do you all know what machine learning is? Okay, we'll get that one covered. Okay. So let me get through the spiel and then we'll take a look at some of those links and some samples that I put together. One of the fascinating things I think about TensorFlow is it is an open source project that was presented by Google, but as we all know, Google's not the only quote unquote cloud provider that's out there. And so I took some time and I just wanted to take a look and see, how is things like AWS and Azure, what are they doing with regards to it too? And sure enough, it turns out that they have their own versions of it. And if I can get this to work. So if you do a search for TensorFlow and AWS, sure enough, there it is. This is interesting to me for several reasons. If we take a look at, in the wild, how do you actually use TensorFlow? Well, the way I always looked at it is there's basically two sides to it. There is rapid development, okay, something that we're going to do probably on our own laptop, for example, which, they tout TensorFlow will run on your laptop and supposedly will run on your phones, although I've never tried it. And then there is production use of TensorFlow, which is going to be for mass number crunching, where we're going to basically start to see like cloud computing come in, where we can throw tons and tons of resources at it. Okay. Well, my interest in it becomes to the point where if I have a client that comes to us and say, hey, we've got some machine learning we want to do, we want to use TensorFlow, so these are all just keywords you're throwing at me. I'm going to sit down with them and we're going to start to have some discussions around the most important thing to them, and that's the bean counter, is like, well, what's your budget on it, right? Because if I run a simple application, which I'm going to do an example of here on my machine here in just a minute, I can handle it with my machine, so the computing costs on it are pretty low. But if we start to look in for doing like maybe cost predictive or market trends for like housing, for example, well, this is where the compute numbers are going to go up and up and up. Now as an organization, you have a few different choices. First choice, back in the day, they're probably going to run it in-house, meaning they're going to have a server farm in order they can use the resources that they need. So there's costs associated with that too, right? Because not only do they have the computers and the hardware that's going to cost them money, but they have to have a staff on site to manage these machines. And they also have the technical expertise to set up, network these clusters together, install the software, keep up on all the updates, and then run the products. All right, so that's old school, the way I like to look at it. Of course, the trend nowadays is they're moving more towards cloud computing, which is really where my team comes in. We have a client that come to us, we have a process that we built internally, but we are ready to scale. And we're done doing, we don't want to do it in our own data center now, we want to take it to the cloud. So at that point in time, we have to sit down with them, we have to start having some real conversations around, well, what are you trying to do? What does your average run times look like? How much processing power are you currently throwing at it, and how do you want to scale this going forward? Okay. And then the next question that we follow up with that is like, all right, so do we want to do something called like a lift and shift, where we literally take your model, your software, your solution, and we move it from in-house to a cloud provider, be it AWS, Azure, or GCP. Okay. We need to start to have those conversations. And then the next question is, if you don't want to do a lift and shift, do you want to start to cut down on some of your man costs? And there's ways to do that. With Google, for example, and AWS does this and Azure does it too, they have machine learning solutions out there where you can start to take your data model and without having to spin up or know about the clusters of computers are spinning up in the background, you can literally just take the model, upload it to the cloud, and then start to schedule it to run. And typically, like in Google's case with machine learning, which is essentially what they're using, it's all hidden to us as the end user. We go in there and we say, hey, we want to set up a job to run on the machine learning engine, and go ahead and do your thing, Google. Well, if we don't start to put some checks in place, those jobs can start to scale and scale and scale and scale and scale. Along with that, as they scale out, the run times, and they're going to start to cost us money, right? So as a DevOps guy, I guess you could say, if I'm going to use that title now, my concern isn't so much going to be about what your models look like, more so about what are the impacts and what are the resources that you're going to need. So we're going to have to sit down and start to talk about that so we can plan costs. It never fails with the new project when it comes out. They've already got 9 out of 10 times some type of solution in their background. So they've already got their models created. But what they're really interested in is like, what is it going to cost me to run this? What's the cheapest way to do it? And then outside of that, of course, the next thing is going to be like, how do we get access to the data? Are the jobs going to be batch jobs where I just, load up all the data, I run the job once, I shut it down, and then I output the results? Or is it going to be streaming where we got constant data coming in against this model? And are these resources going to be running constantly? So, like I said, ADD, so we'll jump around a little bit. Those are my main concerns. Some other interesting things out there is if we take a look and we want to talk about, I think, TensorFlow in general, I think we got to ask ourselves, well, what are some of the other alternatives that are out there? Can you all think of some off the top of your head? Torch. Okay, that was one.
CNTK.
Okay. See, so there are other options out there, and I kind of wrote down some. Kafka was another one that came up. Torch, yeah, it's right on there. Hey, look, did you read that off my list? That's what I thought. Okay, so these are out here. Now, here's my favorite part. I took a look at it, and I wanted to present a well-rounded, I guess, cover of TensorFlow in general. And so, whenever I look at or I wanted to analyze a software solution, my favorite thing to do is open up my search engine, and I think I even put that in parentheses. I did this with DuckDuckGo because I don't use Google too often for that stuff. But what I searched on was my favorite saying is why TensorFlow sucks. I mean, and I'm trying to be, I want to present both sides to it. And I'm not saying that TensorFlow sucks. But I do think that whenever we look at a software that we're going to use for any purposes, that we really need to weigh the pros and the cons that are against it. And so some of the disadvantages with TensorFlow in general is the adoption rate is great, and we do see it a lot in production environments, but it's not an easy thing to get in and start to use. There are some background skills, and I heard a side conversation, Sarah, so I'm going to pick on you for just a minute. So, and I think the gentleman behind you too that sports my same haircut, maybe a little shorter. But, and that's that with TensorFlow, it really isn't an easy tool to use right out of the box. You have to have some, I guess you could say, some industry knowledge. You have to understand how to build the models, linear regression, things like that. But you also have to build the right software, right? You have to understand Python. How do you build these out in Python? How do you deploy it? So there is, I guess you could say, a learning barrier to get out there and use it. And so this is actually a really well-written document. I'm going to see if I can pull it up. We won't go through the whole thing. But it does hit on some of these points about the fact that, yes, there's a huge adoption rate out there on TensorFlow, but there's some huge challenges to go along with it too. And a lot of it has to do around with the learning rate. In general, it talks about maybe a comparison to other frameworks and how hard it is to use. One of the key things I like in this document, I like PyTorch, by the way, it was one of the other ones I was looking at. But the gentleman that actually wrote TensorFlow, and I wish I would have put this in my notes directly, he's no longer at Google. Guess where he's at now? Facebook. Yeah. Damn it! Okay, yeah, so, but the cool thing about it is he went to Facebook and they're actually working on an alternative to it. So basically, what that tells me, if I have to make any inference from it, is that he realized that with TensorFlow that it was an improvement in leaps and bounds. But when he got to the end of it, he was like, oh wait, there are some things that I can do to make it better. And so he took those high ideas, went to somewhat of a competitor, and they're working and pushing us forward now too. Now having said that, the big news that came out this year is that they just released, or they're in the process of releasing TensorFlow 2.0, okay? And so what does that mean is that they put another layer, and this article talks about it too, is the fact that you've already got this low-level API, really hard to work with. And so, in fact, I think it's at the bottom. Yeah. So they list out this guy here, Kuras, which I'm probably saying wrong.
Keras.
We're going to go Kuras. I've heard it both ways. Anybody get that reference, by the way? Psych, best show ever. Okay, so Keras, is that how you say it? All right, so Keras is basically another API level they put on top of TensorFlow to make it a little bit easier to work with in server. Shaking your head, yes, right? Well, apparently the industry recognized this too, because with the announcement of 2.0, that's essentially just the marriage of Keras and TensorFlow. So even TensorFlow has kind of come out and said, yeah, okay, we realize this isn't the easiest thing to use, so we're going to help you out make it a little bit easier. So, get back to my notes. Okay, so another fun fact, and one of the other things I like to do whenever I'm researching a proposed new software in general, is I like to look at an adoption rate, and I like to look and see how it's distributed across different languages. I'm a software guy, right? So I want to know about, who's using it, Java, PHP, Python, C#. I hate the fact that they list TypeScript, but that's besides the point.
Isn't Juniper Notebook Python and R?
Yeah, why is that on there?
Yeah, it's not a language.
Well, we can take a look. I got the link up here.
Yeah, that too.
Yeah, with Jupyter Note, there's actually more to it than just that, because with Jupyter Note, typically what you have is you have a server that's presenting these web pages that are interactive, right? Because that's essentially what a Jupyter Note is it's a HTML page, and we can go in there and we can put code in line and then run it. So I can almost make out why they would list that separately. And a lot of it is, and this ties back to Google's best practice. I have a team of 5 people who is working on this machine learning project. They're using Jupyter Notes for different reasons. Their solution to it is that you all have your own Jupyter Note accounts, so to speak, but then what you end up doing is you work with a shared repository, which is essentially what we would see here with the listing here. But this was sad to me when I saw this. 168. I mean, TypeScript has it beat for all things. So, what are those numbers? What is
Yeah, what is that number?
Oh, so what I did is, and we'll just do that real quick.
It's probably technology is one of the languages.
I went out, it is, because it covers, basically it's looking at projects and everything else. And so I like to go out to GitHub whenever I look at something new like this. And I just put in a simple search. I probably spelled it wrong, now I'm being self-conscious. Okay, so I just did a search for TensorFlow, and I wanted to see, and this basically breaks it down for how many projects or references, and then the languages for which it falls underneath. To no surprise, though, of course, the top one is Python, right? That was no shock to me. And then, like I said, with the Jupyter Notes, these are probably just repositories of different notebooks that are out there. In fact, I know they are because I took a look at a couple of them. And so if you wanted some examples to work through, I think it was this one. These are notebooks that you can download and then probably run it through something like Google's support of Jupyter Note, for example. But my curiosity, I wanted to see what they're doing with this, and so I actually bookmarked this tensorflow.net. And reading down through the README file on it, essentially what they're doing is they're creating a wrapper around the Python wrappers to expose the functionality for TensorFlow. And if you looked at, we've all looked at some of the simple examples that are out there, and I don't know how well that shows up. I don't know if I can zoom in on this or not. But ironically, it's almost like they've just done a one-to-one conversion. So like you see the samples on your left in Python, and then your examples on the right in basically .NET. And essentially what, like I said, they're doing is they're taking the Python classes and putting a wrapper around it so you can expose it to another language. Let's see. Okay, another good thing, and we're talking about Google in general. When you use their machine learning engine, which is basically what they would use to support like your production regular TensorFlow. When you set one up, and we can take a look at it in a second if you want, you're going to specify in those instances, or do you want to use a CPU, a GPU, or a TPU? Okay. So all other cloud providers, AWS, Azure, for example, have similar services, and they basically allow you to use a GPU. And we all know why, right, on the GPU? I'll just kind of break it down. Basically, with the GPU, the graphic processing unit, it handles the transactions a hell of a lot faster than a typical CPU. And so time is money, and essentially, especially when you get these jobs done faster, you want to throw a ton of resources at it. On AWS or Azure, you're going to throw a process at it that's going to run on a GPU. Well, Google wanted to separate themselves and make themselves a little bit different, right? They're the ones who basically came out with this open source project to begin with. Well, they took it a step forward. They've got the software side, but they also wrote something called a TPU, which is a tensor processor unit. Essentially, there's performance, I don't think I put it in this, but there's some comparisons out there, and it's quite a bit faster. And so from a, not being a salesperson for Google, but this is one of the things that they would stress on how they handle machine learning better than everybody else. They have more quote-unquote technology around it.
So if you were to do like a ballpark estimate, how much faster is the TPU versus GPU?
Well, I don't know the answer to it, but we can do this.
Or my phone?
And I think what it's going to come down to is who's doing a comparison.
Yeah, if it's NVIDIA, then probably.
Well, this is on Tom's hardware though, so it might still be fairly neutral.
2 years old.
That too. But it was the top list, or the top item on the search result. The search
It's probably in favor of, yeah. Probably in favor of the
Well, once again, I'm not using Google to do my searches, I'm using DuckDuckGo, so. But yeah, you can take a look out there.
Yeah.
Now, ironically enough, we had a proof of concept, and I won't name any names or anything on the customers in question, and it's not the one that you're familiar with, I think. But, so remember how earlier I was talking about how people come to us and they say like they have processes in-house, but they're ready to scale it out from there and move it to the cloud? Well, we had such a proposal come to us, and another company that's a big company put together a proof of concept based on Google's technology, and they went through the process, they set it up, and I think in this instance they're actually still using the GPUs and not the TPUs, but the cloud-based solution performs 70% slower than what their in-house solution did, and it was a real shock. Well, they got the engineers involved at Google to take a look at it. And what they realized is it's actually internal networking inside of the computers. And I'm going to draw a blank on what the technical differences were. But the in-house solution, their engineers in-house that had actually built out these the hardware to use, had just done a better job of engineering a solution that worked for that specific case. And I haven't heard, it's been about a month, but supposedly Google is actually going to take a look at inside their data centers and see what they can do to address this particular instance. The client was a pretty good client, and Google is out there right now, because as far as your cloud providers are concerned, they're way behind when it comes to AWS and Azure. Way behind. And so they're being extremely aggressive to get their business and bring it back up to the point where in some cases they're giving away their services for free just to get people onboarded. It's interesting, and so like we have clients that are somewhat jumping ship from one provider to Google just because of the cost savings that they're going to see. Of course, now it needs engineers like us to move those solutions from one provider to the other. So that was a tangent. Told you I'd do that. Okay, I think I mentioned that. Yeah, TensorFlow 2.0, which was just announced. So let's take a look. So there's tons of tutorials that are out there, and like I said, I'm not a data scientist. I'm more interested in how do I support TensorFlow than anything else. But TensorFlow has some really good general tutorials that are out there. Is this the one I went through? Oh, this was another one I'm looking at. I'll talk on this one for a second.
LCMs are cool. Long, short term.
This one was fun because this was a case where we had another potential client in Texas. It's a big town down there, not Dallas, another town. And their metro system wanted to basically put together a process for doing some sentiment analysis. And so, Sarah, actually, this is the one that you and Michael really worked a lot on. And so this was a case where we were able to put together a solution for them that relied more on Google's internal API. So they have a natural language API that basically handled what we needed. But we went through the process of building this out through TensorFlow, hosted the solution out in GCP as a proof of concept. And yeah, it was kind of cool. So, come on, watch. Oh, actually, I took about 25 minutes there. I have an example if you guys want to see it. I can bring up the code, and that's about what I have. So this particular instance, and I'll run it here in a second so you can see it. Basically what it's doing is it's going to take some handwritten numbers and it's going to run some analysis against it to basically tell us what those numbers are. So in this case, what I found was interesting, let me make this big, is they're using a JavaScript. It's a wrapper. It's still coming out to another server that's actually running TensorFlow. But the tutorial breaks it down. You can actually go through the script and kind of see what's going on. So let me just bring up the script first and see if I can zoom in on this. Okay. So the cool thing about TensorFlow, because of its adoption rate, there are tons and tons of extensions that are written around it so you can have support in other languages. And here's a good example. This was actually written in JavaScript, but it's still doing the same thing. It's essentially using the TensorFlow wrapper to make the calls inside of there. This was a fun, and I have this link and I can share it with Sarah if anybody's interested in it. But basically, this is going to take about 10 different images and run through the analysis on it, break it down to the bits, flatten it out so that it's a bunch of zeros and ones, and you'll see the process. So I'm going to go ahead and just run this now. It talks here about the weights, the losses, and as you go through the tutorial, it kind of has you make some small adjustments to it so you can see how fast. Interesting enough though, when I was running this, was to see how much it slowed my machine down. So the technical solution here, there's 3 files. Let me get out of this. And I don't know if you can see this well enough, but the 3 files that we're going to be interested in is the data.js, the index.html, and then the script.js. The other ones that you see in here, the node modules filter, package lock, and the server, that's Node.js, which is essentially what it's using to stand up a web server so that I can run the index.html. And when the index.html runs, it fires off the script.js, which in turn works with the data.js if you're interested in how it works. And if you look over here, on this one, you can see here that it says server running and it gives me a port number. So if we come back, I bring up my local host. And we hit that port. And then index.html. Okay, so there's the input data. And you can see it's starting to run. It's going to start to produce some visual graphs that you can see. Excellent. But it probably doesn't come through this very well right now. But my machine is just getting bombarded, and the performance on my machine is just going down and down and down. When I was running this earlier, I finally closed it out because I was like, I just can't stand it. But I think this small problem is a good example about some of the requirements that are needed when we start to look at actual requirements for some of these big jobs that are out there. So, okay, that's all I got. Thanks for letting me talk for about 30 minutes. Is there any questions that I can attempt to answer for y'all? Yes?
Have you heard of the Coral board?
Say that again?
Coral board?
I have not.
It's a Raspberry Pi-like board that
Okay.
they recently released with TPU on it.
Oh, really?
Yeah, it's about $150, and they're also selling USB plugins with a TPU.
Serious?
Yeah, for
That's kind of
85.
cool.
I think they were $75, $80 on those.
Okay.
What's
So-
it called, the Coral?
Yeah, Coral board, and I don't remember what their USB plugins were, but they were by the same company. So if you look it up, sure.
Yeah, right here.
Yeah.
Looks like your story checks out.
It better, I just looked it up.
That's a nifty little camera.
Yeah, we have a Raspberry Pi at home. I helped my daughter in 8th grade in her computer science class. But what we used it for was launching darts, which was really cool actually. So a pneumatic tank and then a sprinkler valve. And then we basically used the Raspberry Pi so we could program it with an actuator to aim up and down, left and right. And then there was just a 0-1 command that we sent through to open the valve temporarily and launch the dart. You should see what happens when you turn that over to a bunch of 8th graders.
Did you make a video of it?
I didn't. I should have. So I actually had more fun than I think they did on that one. So.
I want the same thing that recognizes flies and uses a laser.
That would be cool.
And dangerous.
Yes. So I was at Microsoft's Build. This was about 3 years ago. And at the time, machine learning was really, really kind of a big thing in Microsoft's eyes too. And if you go to a Build convention, like I've been to other ones as a software developer, and they're really cool because you got a bunch of workshops where you actually are what I call learning. Build is not like that at all.
I call them.
Build is basically a way for them to get a captive audience and then force feed you their product for you to buy and buy into. But one of the demos that I went to, they were using Entity Framework, the newest, latest version, .NET Core, and they were building a shopping cart. But what was cool about it, which Google was already doing this, but they were using their machine learning APIs that they had available for recognizing products. And so you could, you could build your own where you could drop an image of, say, like a jacket, and it would go out and do the search for you, which Google already does that, right? But it's kind of cool to go through the process and build it. And honestly, I think that was the only session I went to that I actually could tell you about today, because the rest of them I just kind of tuned out anyways. So, anything else?